All right, Anthony, what would you like to talk about today?
Let's start out by talking about monitoring. So in a traditional VCS cluster, we have the application. So the app itself can be up or it can be down, but what we're concerned about is what the cluster thinks. So VCS from an app, it thinks it's up. Well, what happens if that application goes down? The app goes from green to red, now it's offline. Well, the way agents work is that they're sent or they're issued once a minute. So we start at the 0 seconds, we move from 15 seconds, we move to 30, and then finally, after 60 seconds, we're guaranteed to run another monitor. But at any point throughout there, we could run that monitor because we're running one for every application on the cluster. So whether it's at the 0 seconds or it's at the 60 seconds, you don't know. At that point, VCS changes its state to offline and has the application take some action. So this is just traditional monitoring.
So in other words, we're just going through a polling and checking sometime during the 60 seconds of finding out if an application's up or down, right?
Yes, that's correct.
Okay.
And this is for every application on the box, whether it's the service that is the disk group, the mount point, the IP address, every service has to run this. So the more you run, the more applications you have in your cluster, the more polling you have to go through. So traditional monitoring goes that route. We go and we take this new framework that we have for the application now with poll-based, or with intelligent monitoring, IMF, our intelligent monitoring framework. We have that same framework where VCS and the application have their own status. So the application now goes from green to being online. VCS goes green from being online to red. Something happened to the app and now it's faulted. Well, at that point, at the 0 seconds, we detect that a change in state has happened for the application. Immediately, VCS goes and does an offline. Takes action corresponding to what's configured in the cluster.
So what's the difference here? How come we catch it so quickly? What have we done in order to make that happen?
Within intelligent monitoring, or IMF, we've gone and put a layer in the kernel that's just watching this instance of the application. When it changes state, when it goes online or offline, it's going to know, based on its registrations, that it's changed state. We then can go and tell VCS that it has changed.
So it's an immediate recognition rather than having to wait for a polling cycle to occur.
Absolutely. There are two changes, or two benefits to intelligent monitoring. And first is that initial immediate notification. And the second is because we're not having to run the poll-based monitoring, that we know every single resource's state at once, no monitoring needed. So all the CPU and memory being utilized by those hundreds of apps on the box is no longer being utilized. They're all freed up for the app itself.
So the two benefits really are here. One, it's a faster recognition of a fault,
Correct.
right? And secondly, we're not putting as much stress on the CPU and memory, and so consequently more things can be done on the box. Would that be fair to say?
Absolutely, that's correct.
Okay, fantastic. This is a great explanation of what IMF does.